All right. So in today's lecture, we're going to talk about data acquisition. So in the last two lectures, the first was introduction. Then we talked about the laws. What are the different laws that affect digital forensics and how to get a warrant, how to get a subpoena, what are the differences and so on. In this week's lecture, we're going to talk about the data acquisition, like how you acquire the data. For example, if you are given a case, how will you prepare for data acquisition? What steps you need to take there, and how you should copy the data from the suspect's computer to your own hard drives and so on. If you want to read the book, like it is chapter 3 on the book. So for further reading, you can always go to the book and read chapter 3 there. So let's assume you are a digital forensic investigator, and your first job, you are given a case where a student allegedly stole an upcoming test by copying it onto a flash drive, but was caught in the action. The flash drive is now secure with the police department, and you have been tasked with making a data acquisition. So your question for you guys is that how would you make this data acquisition? What should be your steps, and how you would proceed to this case? All right. So yes, the answer is right. We will make a deep copy, but like the first thing that comes in mind in most of the times, like in people who are not familiar with digital forensics, is to just copy paste all the contents that are there, right? But that copy pasting is not the right option. And the deep copy is the only option that you should be looking for. And yes, like once you make that acquisition, you have to start the chain of custody documentation and make sure that you maintain it. So the issues that are there with the traditional copy paste approach are threefold, or there are many, but we will discuss them one by one. First are the hidden files. So if the suspect hides some file from the plain view inside that flash drive, like you can just right click, go to any open any hard drive, right click on any file, and you can hide it. So the first issue is that hidden files, like if any file is hidden and while before making the copy, you didn't unhide them, or you didn't reveal them, then you will not be able to copy those contents or those files. The second one is deleted files. So if you guys remember, I've been stressing on this, that there are two things. First is whenever you open your my computer or anything like that, all the files that you see there, that are the files that your file system sees. All right. And how it works is that a file system has a directory of file names. You can say file 1, file 2, and so on. And it has pointers to the hard drive locations or sectors where those files are stored. So what commonly happens or generally happens is whenever you delete a file, the content in the hard drive still remains. Only the pointers that are pointing towards the different sectors are deleted. So if you delete a file, that file will be deleted from your view, but the content will still remain inside the hard drive unless it is updated by some other file, or unless it is you format the whole hard drive. So if you have any deleted file, then no matter what you do, you will not be able to see those deleted files from the user's view inside that pen drive or inside that flash drive. So if you just copy this, then you will be missing on the deleted files as well. Another thing is the metadata. So metadata of a file, such as the creation time, the last modified time, the last open time, these type of things. Generally, the operating systems save this type of metadata for all the files that you have. And every time you do some process with them, for example, you open them to just see what's inside, you move them and do other operations. The metadata, there is a chance that it will be modified. So you want to make sure that you don't want to mess up with the metadata, because it is crucial part in investigation. And you want to know, like when the student was caught while copying the data, and also compare that time with the file creation time on the hard drive or on the student's flash drive. Compare those two times and see whether that act actually happened or not. The other thing is when you do a simple copy paste, there is no integrity check. So like always in digital forensics, whenever we are acquiring the data, we want to make sure that the data that we acquire, the copy we make versus the data that's on the hard drive, they both are same. So to do that, we can, just simply take the hash, any type of we can use any hashing algorithm, and we can take the hash of the hard drive, and we can also take the hash of the content that we copied and compare those two hashes together. And if they match, that means we correctly copied all the data. There is nothing wrong with the copy that we made. But if you simply copy paste, there is a chance that you will be only copying the data or the files that are, in your plain view, but originally there will be a lot of content on the hard drive and there will be a clash. You will get two different hashes. So data integrity check is another option. The other is evidence tampering. So again, evidence tampering is related to metadata. If you are, like copying stuff, or if you open stuff to see what's inside the file, you will be, like changing the metadata. There are other issues too that we will, like looking into in great detail in today's lecture, and we will see what are the different types, or what are the different, methods using which we can copy the data from the forensic artifact to our own hard drives. So any questions so far? All right. So today's lecture, not today's, but like overall, generally the week, we're gonna like list down what are the different types of methods that you can use to copy the data. What are the different type of tools that you can use? What to like consider when you are like copying the data. We will also talk about the RAID acquisition systems methods. So RAID is like you can say a storage type. We will discuss that in detail, and we will also look at how you can acquire the data remotely. For example, if you are working on a networked system and you don't have the physical access to the PC, how you can acquire the data over there. And we will be also talking about the different types of acquisitions as well, like static acquisition versus the live acquisition. So let's start. First, we have the different types of acquisition. So there are two basic types of acquisition, or the ways in which you can acquire the data. The first one is the static acquisition, and the second one is the live acquisition. So in the static acquisition, you capture the data that is not accessed by any other process. So for example, like you have a PC that's turned on, and that PC is handed over to you to collect the data. So what you can do is you can pull out the hard drive, put a write blocker on it, and capture whatever is inside that hard drive, make a bit-to-bit copy. And it is like typically done on the devices that you have already seized. For example, like in previous case, you have the flash drive that is captured, or that is in the possession of police department now. They can give you the flash drive or the computer, and you can try to make a copy. But the general idea here is that in static acquisition, the data that you are trying to copy, or the like memory medium from which you are trying to copy, it is not used by any other process. So for example, if a PC is turned off, it is not being used by any other process, right? Similarly, if the police hands you over the flash drive that is in your possession, you can plug it into the PC whenever you want. It will not be used by any other person. But the issues with static acquisition are that sometimes the data can be, encrypted, or there can be some type of password protection. Or the third case is that, like you don't have the physical access to that, to the memory medium. You can only access it remotely using the network connection, or using some other type of software. So in those circumstances, the static acquisition is not, like ideal, and you have to go with the live acquisition. So we'll discuss these two in detail as well. So in the live acquisition of the data, mostly you are like focusing on, two things. First is the hard drive, like what's on the hard drive, what softwares are stored there, what data is on the hard drive. But you also look at the memory content. So RAM is an important memory content. Like you can find all the programs that are running on a device. They are loaded inside the RAM. You can also, as I mentioned earlier, if the like files are encrypted, or if there is, any type of password being used on files, it is sometimes only possible to acquire them through live acquisition, because, like when something is running, then you already have like the encryption key plugged in, or the password plugged in. And if you turn off the system, then all the RAM content will be lost. So depending on the case, sometimes you want to go with the static acquisition, or sometimes, static acquisition is the only option you have. Other cases, you can go for live acquisition as well. All right. So the idea here is that you have a hard drive that you like captured, and inside that hard drive, you have some files that are encrypted. So even if you make a bit by bit copy, will you see the encrypted versions on your copy, or will you see the actual versions? All right. So whenever the file or the content is encrypted, even if you copy that content, it will still be encrypted, right? You will not be able to see the plain view. That is one of the drawbacks of static acquisition. That if you do the static acquisition, you will have to decrypt these files on your own. So other option is, if like, the computer is running and the user has already decrypted these files and they are open in the computer, for example, they are open in RAM and so on, you can do the live acquisition. And doing that, you will be able to capture the plain text of these encrypted files. Similarly, if the files are password protected, there is like, depending on what type of the protection is used, sometimes you will be able to see the files in plain view. For example, if it's just the password protection, then you will be able to see the files in plain view if when you copy it bit by bit. But if that password protection is also like somehow encrypting those files, then those encrypted files, you need the key or you need the password to see them. There is no other way. So there is an example like now on, like Microsoft and Mac, they both provide you this opportunity to encrypt the data on your hard drive. So even if somebody has access to the hard drive and they don't know the key for the encryption, they will not be able to see your personal data that you have encrypted. All right. So let's dive deep into the live and static acquisition and see what are their limitations and so on. So static acquisition is always the preferred method because it gives you, like a bigger opportunity, a wide range of options to acquire the data, but it has its limitations. What are those limitations? First is the encryption or password. So, if any file is encrypted or if any file is protected by the password, it will stay encrypted even if you make a bit by bit copy. So, one thing is to decrypt them using the tools. You can use any password breaking tool and try to figure out the encryption key. The other way is to go for the live acquisition because when the PC is running, then the content that you will be seeing will be decrypted automatically by the system or by the user. The other drawback or limitation is that in order to do the static acquisition, you need to have physical access to the computer or to the suspect's drives or memory mediums. So if the drive or the computer is only accessible by network, then there is no way that you will be able to do the static acquisition, and you will always have to do or go with the remote acquisition or live acquisition. Live acquisition, the advantages are that even if the files are encrypted or password protected, when the PC is running, that encryption is taken care of by the user himself or herself, and you will be able to see the actual or the plain view or the plain text when you do the live acquisition. One drawback of live acquisition is that, like in static acquisition, you are not doing any operation on the suspect's hard drive or the physical artifacts that you collect. Whereas in live acquisition, since you have to run tools or programs from within the PC or remotely, you will be like leaving some type of footprint on the content of the data that you are trying to copy. So for example, if you say remote login to a device and then start to copy all the content of that device, since you are doing remote login, you are tampering with the RAM, right? Because there will be a new process, remote login process, that will be running on the suspect drive now. So the drawback is that, like if you are trying to do live acquisition, you will always be tampering or you will always be leaving a footprint on the forensic artifacts that you are trying to copy. All right, so we have discussed the two different types of acquisition, whether to do the live acquisition or the static acquisition, what are the pros and cons. The other thing, or the main thing that we do in this whole process is copy the data from the suspect's machine or suspect's drive to your own machine or to your own drive. So how to copy that data? So there are basically 3 or 4 different types or different ways in which you can copy that data. The first one is a disk to an image file. The second is disk to disk, or it is also called disk cloning. And then we have the logical disk to disk or disk to file or image files, copying machine like methods. And lastly, we have creating a sparse data copy of a file or a folder. So first, let's talk about the first two options. The first one is disk to image. So disk to image copying method is the most common method that generally you use. What you do is you try to make sure that you copy all the content of the data bit by bit from the original source to your own hard drives that you wanna use for your forensic investigation. There are some tools. So we will be using FTK Imager. So in disk to image, what you do is, for example, if this is your hard drive, which contains some data, there are some empty spaces, some more data, some empty spaces, and so on. You copy all the content that is out there, and you copy it into an image file, or you can say, an ISO file or something like that, that you can use to transfer from, like the suspect's drive to your own drive. So the key goal is that, or the idea is that disk to image, it copies everything bit by bit to the drive, but to your own drive, but it makes or gives you an option to create an image file out of it rather than creating the replica of that hard drive. The other option is disk to disk, or it is also called disk cloning. So in this disk cloning, you not only copy the data from the file, you also copy the OS data as well. So when you do disk to disk, you are basically making the exact same copy from the original one. So for example, if this is your original and this is your copy, you have some data here, then you have some empty space. I will denote it like this. Then you have some more user data, empty spaces, and so on. So in disk to disk image, you need to make sure that the content or the hard drive in which you are copying has at least the same size or larger size, because you are copying bit by bit, including these empty spaces. So this is the big difference between disk to image and disk to disk copies, that in disk to disk image, you only look for the data, and if there are like empty spaces in the hard drive, you leave them because there is no data there, right? But in disk to disk, you are making an identical clone. Even if there are some empty spaces or regions in your hard drive, you are leaving them empty in your copied version. So since you are not creating a file like an ISO in image case, in disk to disk, your copy, you can just replace this copy with the original device, and you can also boot up the operating system from this device as well, or this copy as well. So this one is identical replica, including the OS information, including the empty spaces, and you can just swap these two and they will still work. Like you can boot your PC from this cloned disk as well. Whereas in disk to image, since the only difference is both of the cases, you are copying all the data that is out there. But in disk to image, one thing is that you are creating an image or a file. Over there, you are creating a replica, the same hard drive. So this file, it is, you can boot from it, but you will have to mount it on some other hard drive and then work from there. But generally, you cannot swap this imaged file with the original disk. The other option is, since we are not copying the empty spaces, this thing will be smaller in size, right? So disk to image, why it is more popular? Because first is that we ignore, or we don't copy the empty spaces, so the resultant file is smaller in size, so we can save some space out there. The second one is this copying mechanism is a bit faster as compared to disk cloning. And the third option, or the third feature that favors here, is that in this operation you can also compress the data. So due to data compression and not copying the empty parts, this is like more preferred, or efficient way of copying the data, because you are saving the space. But the general principle for both of them is the same, that you have to copy bit by bit, like all the user contents, including the operating system that is there. All right, so this is like a one-on-one chart, or you can say comparison for disk to image and disk to disk. So in both cases, you copy everything bit by bit, including the OS operations. Disk to image will produce a file, whereas disk to disk will produce a copy or identical copy of the hard drive that you can swap as well. This image cannot be used to boot, on its own, and you will have to mount it on some other hard drive if you want to do the booting from it. But the disk to disk copy, you can just you can replace it with the original, and it will still boot your system. This to image is smaller in size because of two reasons. First, data compression. That's one option that you get here. The other one is you are not copying the empty spaces that you can copy from when you are doing disk to disk. The other one doesn't provide you this option as well. The resultant file or data that you will have in disk to image will be a data file, say, like ISO file or something like that. Whereas disk to disk, you will have a complete running disk, that you can use. So, like from the exam perspective, just understand like the differences between the two. What are the common things between the two? They both copy bit by bit all the user data. What are the differences? Like, one we have the storage boost, or say uh, this one provides advantages in terms of storage, that it will be smaller in size. It provides us the ability to compress the data as well, and so on. Another thing is, when you are doing disk to image, since you are copying data, you are creating files. If you have a 100 TB hard drive, original hard drive, you can divide it into three different files of 33 GBs and so on. So this way, even if you are investigating and you don't have the right hard drive to copy the data, you have a smaller space hard drive, you can still divide the original data into different copies or different segments, and then move those segments to your own machine. Whereas disk to disk, it is a compulsory requirement that your disk or your hard drive on which you want to copy the data, it has to be at least the same size or larger, otherwise you won't be able to copy bit by bit. So this is another advantage that we have to disk to image type of copying. All right, so any question about the previous two versions? Okay, next we have the logical acquisition or the sparse acquisition. So for both of these different type of acquisitions, we are making or copying all the content that is out there. So we are making bit by bit copies. So it is possible that sometimes in order to save time, or in order to save space, copying space, if time and space are your concerns, you might not get a chance to make these copies, because since you are copying, it will take a lot of time to do disk by disk, disk to disk copy, or even disk to image. So sometimes you can do logical acquisition or sparse acquisition as well. So in logical acquisition, you only target the specific files that you want to copy. So it is ideally you should go for the full hard drive copy bit to bit, but sometimes maybe you just get a chance on with the suspect's device for a limited time, and you don't have the ability to do the disk to disk or disk to image copy. So in those cases, depending on your case, so that's why identifying things related to the case or identifying the scope of the case is really important, because it helps you in deciding these things as well. So if your case is about emails, or it is about the transfer of data, somebody copy pasted PDF files from one device to another. So if you know information about the case beforehand, you can always use logical or sparse acquisition. And in these cases, you can target the type of files that you are looking for. or like you can target one specific area in the hard drive, and you can collect that data only, and you will not be copying the whole hard drive itself. So in logical acquisition, we only focus on the files that are relevant to the case. So for example, in the previous scenario where a student copied the quiz from the or stole the quiz from the instructor, we can just look for the Word files or the PDF files, right? Because the quiz will be either in the Word file or the PDF file. We don't need to look into the media files or emails or something like that. Sparse acquisition, it is similar to logical acquisition, and the idea is it collects you collect the files that you're looking for, but you also collect some other segments from the hard drive in addition to those files. And both of these things, like logical or sparse acquisition, you will only do when you have some limitation. For example, you have limited access to the suspect's device, or you have limited resources. Ideally, the preferred way is to do the bit-to-bit copy by either using disk-to-disk or disk-to-image methodologies or methods. All right. And it is also used for large disks. For example, like if you are investigating a cloud, so there will be, hundreds of TBs or gigabytes, like GBs or TBs of data in a cloud, right? So you don't need to copy all of that. You can only focus on the content that is relevant to your case and only look into those regions of the hard drive or the system that are relevant to your cases. So, if you're investigating like a mail server, which will have a lot of data. Similarly, if you are investigating like a RAID server or another cloud computing platform like that, where you have a lot of like hard drives connected, you can just focus on the content that you want and leave the rest. All right. So now another discussion or question for you, like how would you decide which type of method you want to use? To do that, you have to answer some questions yourself. The first one is, what is the size of the disk that you are trying to copy or acquire the data from? Depending on that, you can make a decision. If you are like investigating a cloud, it will be a lot of data, so you can just focus on doing logical or sparse acquisition. If you are investigating some person who has, say, 1 TB hard drive or something like that, it's a limited amount of memory, so you can always go for disk to like bit by bit copy. The other thing is the tools that you have. So depending on if you just have FTK imager or something like that, you can just do one specific type of acquisition in a specific way. So this is your limitation. Other limitations, the tool you have. Purpose, identify the scope of the case first. First of all, like that's the first point. And depending on that, you will know that if this case is relevant to emails, these are the files that I need to look into. If this if the case is about, some stolen documents or some inside trading or something like that, I have to look for the document files, Word files, or say PDF files or Excel files and so on. So purpose of your like acquisition, like why you are making it, depending on your case, that is another question you need to answer before moving on. And the third thing is that can you retain the source disk or not? So if you can retain the source disk, then you have a big amount of time to make the copies. So you should go for bit-to-bit copies. If, on the other hand, you have limited access, that you can only access the suspect drive for 1 hour or say for 50 minutes or something like that, a limited time window, in those cases, you can go for logical or sparse acquisition methods as well. All right. So next, our topic is to, how to come up with the acquisition plan, because in order to do anything, you have to have, like an algorithm or some set of things or steps that you want to take that can help you in fulfilling or performing that act, perfectly. So when we talk about the data acquisition, before going to, or having access to the suspect drive or computer to start acquisition, first you need to make up or come up with a plan that what type of acquisition tool you will be using, what type of acquisition you are going to do, what is the, like the data that you're looking for, what regions or what things you will keep in mind when you are making the copy. So the first thing is create a duplicate copy of your evidence image files. So once you acquire the data, make sure you make duplicate copies, check them, compare the hashes to make sure that everything is all right. The second thing is to copy the host protected area or HPA of a disk. So what this is, I will discuss in a couple of slides later. But for now, you just have to, like understand that when you are copying the data from a hard drive, it's not just the hard drive only. You need also to look at the HP area or host protected area on the hard drive as well. Then be prepared to deal with encrypted drives. So, whenever you do acquisition, it is possible that the user is using some type of encryption or they are using some type of password protection. So, like be prepared for that. And depending on that, you can shift from live acquisition or static acquisition to the live and so on, right? So these are some of the things that you need to, like keep in mind that what you want to do, like what type of evidence you want to do. Once you have that, you want to make sure that you make copies of it. You want to make sure that you collect everything, all the regions of the hard drive, don't leave anything behind. And then you want to also make sure that, what will you do in case the files are encrypted or not. Once you do that, start your chain of like documentation, chain of custody documentation, and make sure you have multiple copies of the data. So in the last slide, we had the HPA or host protected region, and it mentioned that when you are making copies, make sure you copy data from the host protected region as well. So the question that comes in your mind is, what is host protected region? So in any hard drive that we use, for example, no matter whether it's a solid state drive or the traditional hard drive. So imagine if this is your hard drive, there will be some region on the hard drive or some, like part of the hard drive that is not available to the user. So all your operating system, OS and your user data and so on, it will not have access to this region. Even your operating system will not have access to the host protected area or HPA region of your hard drive. Now the next question is, what the hell is inside this HPA, right? Why it is important and why we can't, even the OS cannot go there. The answer to that is like the HPA contains like the firmware and other tools or softwares or small programs that are written by the manufacturer of the hard drive. So if you are using SanDisk hard drive will have some software or tools at the HPA, and their role is that if something goes wrong with it, or goes wrong with the hard drive, they can, go and repair your hard drive for you. That's why even your operating system will not have access on your HPA or host protected region. And even if you try to copy something or, like when you don't have access to here, you don't know what's inside, right? So when you make a copy, for example, even if you make a bit by bit copy, you will be copying this region. That's something that is, to your view or available to the OS. This region right here will not be even copied. So this is called the HPA or host protected area. So this is like the benign purpose or the actual purpose, that it contains the programs that are used to, configure the hard drive, or if anything comes, like any issue comes with the hard drive, these set of softwares or tools, they repair your hard drive for you. But it can be used for malicious purposes as well, right? If you want to hide something, like hide some data, you can always put it here, and it will be hidden from most of the tools that are there for forensic investigation. It will also be hidden from the OS as well as the user view. How we can access it? So this region, this whole thing is the firmware controlled by the firmware of the hard drive. So if you are able to modify the firmware, you can, make openings in this region, HPA region, and you can put some like malicious data there. You can put some, say, if there are some secret files that you want to copy or take out of the system's view, you can always put them at the HPA. So the benign purpose is that it is there to use or store the firmware and other disk related programs that are used for disk repair and so on. But, and the other thing is that this region is out of the view even for the operating system. And even if you make a bit by bit copy, you need to make sure that you copy this region as well, the HPA region as well. And the malicious use is that you can put some files or some data there. Technically, you shouldn't be doing it because the firmware and these type of things, they are very sophisticated and you don't want to mess with them. But you can, like, you have the ability, so you can. Maybe it just like, crashes the whole hard disk or makes it unusable. The next thing is how you would detect whether there is, like some significant amount of data in the HP or not. The answer to that is, do make a copy of, like, bit by bit copy of your suspect drive. So for example, if when you did that, you have 100 GBs of data, right? That is your copy. Now, if you guys remember, we talked about it on the first lecture or the first week, that when you make acquisition, also see what are the types or models of the systems or the device that the user is using, right? So in this case too, if we copy 100 GBs of data and we suspect that there is some HPA or host protected region and some data is there that we missed and we didn't copy, how will we identify it or detect it? We will look into the hard drive, like just plug in the hard drive, see the manufacturer, see the model number, and see the actual capability or capacity of the hard drive. So if you copy 100 GB and the hard drive says that, it is 101 GB, then you have 1 GB data missing, right? So 1 GB data that's missing, that is your HPA that you were not able to copy from the suspect drive. Like, we have discussed the different types of acquisition, different methods to copy. The next thing is data validation. So as soon as you copy the data, you want to make sure that you validate it to make sure that its integrity is intact. There is no modification to the data while you're using that or while you're copying that. The most famous or the most used technique to do that is the hash. So you can use, like, the famous hashing algorithm or most common hashing algorithm, such as MD5, SHA hashes, like there are different versions of that. And there are also numerous other tools or like hashing algorithms that you can use. So whenever you copy the data, make sure you take a hash of the OS, like the original hard drive, and make a hash of the copy. And if both of them, they are, like copied correctly, they will have the same hash. Other than that, the Linux and Windows, they have their own commands to, like check the integrity of the data or to hash the data. And the forensics tools that we use, such as the FTK Imager, or we'll be using Autopsy too, probably in this lab or in the next one. So these tools also provide you this capability that when you are copying the data, they also take the hash of the data to make sure or to give you the integrity check that the copying process didn't like decrypt or didn't disrupt the original data. So a hash is basically just a function. So you gave it some data, say plain view data, and it gives you a digest or one key, you can call it. So for example, if you give it one file, it will process this file and give you a big number or a digest. So if there are any changes made here, even if one character of a file is changed, this hash or this digest that the hashing algorithm produces, it will be different. So it will be able to give you, like, complete integrity check. So there's a concept in hashing which is called the hash collision. And the idea is that ideally two different files, say file one and file one prime, they should have a different hash. And this is like the strength of the hashing algorithm as well, that, that it should produce different hashes, no matter how slight the difference is in the original file. Sometimes if the hashing algorithm is not that good, it is possible that the two different files, they end up having the same hash. So that phenomena is called hash collision, that you have two different files. Ideally, their hash value should be different, but sometimes depending if your algorithm is not that capable, you will have the same hash or the same digest at the end. So MD5, which I mentioned in the previous slide, is most commonly used hashing algorithm for forensics. It is prone to collision, and there has been, like, it's a documented, well-known thing that MD5 is breakable. So breakable means like you can, have two files that have the same hash. So now a question comes in mind that, if it is broken, or if it is producing the collisions, why do we still use it in forensics, right? Because we should be making sure that there is no corruption or changing in the data, and hash is something to validate that. So if the hashing algorithm is broken, why are we still using it? So to answer to that is that yes, even though MD5 is like broken or it can have hash collision, but the probability of doing that is very, very minute. So that is one reason. The other one is that even if like you have two files or two operating system drives or like drives that you captured from the suspect and they both end up on the same hash with a very low chances, you can still look into the individual files because you have access to the plain text, right, for both of them. So even if the hash is same, you can look into the both and compare them bit by bit with some other tool to make sure like that you identify the collision. So the answer is that the probability is very low that it will have a collision. And the second thing is that even if you have a collision, you will have a chance to like, look into the original file and compare it yourself if they are the same or not. Okay, so we covered most of it. The last thing is like, what are the different formats in which you can store the digital forensic artifacts or in which you can copy the data. So we have three basic types or three different formats in which you can copy the data. The first is the raw format. Then we have some proprietary formats that are used by different tools. And then we have the advanced forensic format or AAF. So this is like a snapshot from FTK Imager. So when you copy the data, this tool, I will give you guys a demo in class next week on Thursday. So it provides you different options. You can use the raw data, like save the file or the disk as the raw data. You can use smart format, EO1 format, and AAF format. So let's look into these different types or formats and see what are the differences or what are the advantages and disadvantages. So the first format in which you can store file is the raw format. And it like the raw format is basically bit to bit copying. So whatever data you have on your like suspect drive, you are copying it bit to bit, nothing else, nothing more, nothing less. All right. The main or say the simplest version or like copying. The advantage is that it ignores the minor data read errors on the source drive. So when you are making a raw copy, the softwares or the tools that you use, even if they detect some, like 1 bit or 2 bit missing or some error over like during the copying, they are able to handle those errors and like you will not be seeing those errors in your final version. The other thing is that it is since it is the basic form, or you can say the most basic format, it is acceptable by almost all the different softwares that are used for digital forensics. So like scalability is another advantage that it has. The disadvantage is first that since you are doing bit by bit copy, so you will need, at least the same amount of like empty space on your hard drive in which you want to make copy, or it should be bigger than the suspect's drive. So space is one issue or disadvantage that you need the same amount of space, so it requires a lot of space. The other thing is that some tools that are used, they might not be able to like ignore the minor errors. So if there are like some sector errors or some other like issues with some sectors of the hard drive, you will not be able to note those issues or note those bad sectors when you do like bit by bit copy or raw, like you store the data in raw format. The other thing is the time it will take. So since it's bit by bit copy, it will take a lot of time to copy the data in raw format. Next, we have some proprietary like formats, and in that we have smart and we have expert witness or EO1 format. So what happened was like the raw format is very basic. It just gives you the copy. It doesn't give you any other feature, right? You cannot compress the data. You need the same amount of space. You cannot have some other metadata such as the case information or something like that. You cannot even validate the data because there is no way for you to take a hash or to make sure that there is no error in data copying. So most of the operating like the acquisition tools such as FTK Imager, Autopsy, and so on, they created over the time their own versions that they are using. And in their own versions, they give you all of these different type of options. Like you can compress the data, you can put the metadata about the case alongside the collected evidence. You can also, like add other information like hash or other information that can verify the integrity of the data, and you can also divide the data into smaller files that will become easier for you to transport. The disadvantages of these proprietary formats: first, it's proprietary, so only the software or the tool or the company that developed that format, unless it's a standard format used everywhere by all other softwares, it will not be that scalable, and it will only be used by that particular software only. The other thing is file size limitation for segmented volumes. So, like when we go to the file system, or I think it's chapter 4 or chapter 5. So all the file systems that you have, some of them they have limitation in like how much how big a file can be. So I think FAT has a limit of 2 GB. So if you're using FAT, your file size cannot exceed 2 GB. So, some of these formats as well, if they are like giving you the data into like some, say files, they have some limitation that you have to make a 2 GB segment, like multiple 2 GB segments. So for example, if you are like copying 100 GB of data, the max you can do is create 50 files of 2 GB each, because this limit is there by the format. All right. So this is a disadvantage as compared to raw format. Raw format, you can just bit by bit copy. There is no need to worry about the file size. So among all these proprietary formats, we have the expert witness compression format, which is also called EO1. And over the time, it has become a standard format that is like, it's unofficial standard. So most of the tools that you see for digital forensics, they all accept and store, save, work on the data that is stored in this expert witness compression or EO1 format. So the EO1 format, or like it was developed by the Incase. So Incase is a company that produced a software for digital forensics. They came up with their own proprietary format that became standard over the time. It provides you the capability to compress the data that you don't have in raw format. It also provides you the capability, like whenever you take or capture any file, you can add the metadata about the case, like who's capturing the data, what is the case about, and additional information like that that you can use later on. Another thing is it takes the MD5 hash of the entire data that it is copying. So since you are hashing, you have a way to validate the copying mechanism and to validate whether the copy that you made it is correct or not. So these are some of the advantages that it has over the raw format. So from exams perspective, you need to know like what are the disadvantages of raw format and why we go to proprietary format. So the three main things are no metadata about the case, no compression, and no validity. There's no way to check the validity when it comes to the raw format. So next we have another format, which is advanced forensic format. So the advanced forensic format, like one thing is the same, like all of these proprietary formats, they provide you the three things: metadata about the case, compression of the data, and the validity or the hash of the data. If you guys remember from the previous slide, we talked about the limited file size, that most of these proprietary case formats, they have a limitation on the file size that you can generate. The EAFS has an advantage that there is no restriction of disk to image file sizes. So even if you have 100 GB disk that you want to clone, you can, using AAFS format, create a 100 GB image file and copy all the data that is out there. So that is the key difference between like this one and the previous one. Then we have the last format that we'll be discussing is smart format. So smart format is specifically it has advantages, or it is designed for the Linux file system. So ext2, ext3, ext4, XFS, BT, RFS, and so on. So we'll discuss some of these file systems later on in this course. But for now, things to remember is that smart format is designed to work on the Linux file systems, and it has all the other traditional features of proprietary format as well. That it provides you the compression, it provides you the integrity check, and you can divide the files into multiple files.